Hello everybody. In this video we're going to take a look at constraints in Maya. Constraints behave somewhat like parenting. So let's take a look at parenting first. And you will probably remember from earlier videos that to do the parenting relationship in Maya, you first select the child and then you, in this case, shift select what's going to be its parent. So in this case, the yellow cube is going to be a child of the red cone. And then I can type P for parenting on my keyboard, and this will nest the child underneath its parent. Constraints behave very similarly to parenting, but we set them up a little bit differently. This time, instead of selecting a child and then a parent, I'm going to first select what is going to influence. In this case, it's going to be the red cone. And then I'm going to shift select what is going to be influenced. In this case, the yellow cube. And then I'm going to go to my animation menu set. If you have it set to modeling or something else, change it to animation, and then come over here to constraint, and you'll find the parent constraint here. I'm going to open up its tool settings and go to edit reset settings just to make sure that they're currently set to the default, and I will apply. So what you should notice here is if we look in our outliner, you'll see that the parenting example here, that we have our cone, and then nested and indented underneath is our cube. Cone is the parent, the cube is the child. With the constraint example, we have the cone and we have the cube, but you'll notice that the cube is not a child of the cone. It is not nested underneath. However, the cube does have this plus symbol here, indicating that there is something underneath it. And if we expand on that, you'll see that that is the constraint, the parent constraint that we just applied to it. So with this example, the yellow cube is constrained to the red cone. It is parent constraint to it. So let's compare the way that these two examples work. So with the parenting, if I grab the parent, in this case the red cone, and I move it, the cube moves with it. If I select the constraint example, it behaves similarly. If I rotate my cone, it responds this way. And with the cone example, if I rotate it, it responds identically. And if I scale the parenting example, I scale the cone, it reacts this way. And if I select the constraint example and scale it, it, on the other hand, reacts this way. Let's compare these two by scaling them both at the same time. What you'll notice is that the yellow cube is not changing in size and scale with this constraint example. So more or less, the parent constraint, which is here, behaves as if it were parented, with the exception of scale. Let's take a look at another type of constraint. So what I'm going to do is come over to my outliner and I'm going to select the parent constraint here and I'm going to delete it. So now when I move, or rotate this cone, or scale it for that matter, this cube here doesn't react in any way because it no longer has any relationship with this red cone. What I'm going to do this time is try a different kind of constraint. So again, we apply it the same way, however, that we applied the parent constraint. You select the influencer first, and then shift select the influenced, go to constrain, and this time we'll try the point constraint. I'll once again open up the options and go to Edit Reset just to make sure that I'm applying the default settings so that you can see what they do. And we'll go ahead and apply. So the first thing I'm sure you noticed is that when we applied the point constraint, our yellow cube instantly popped into position in the same place where our red cone is. Now, if I move this red cone, you'll see that the yellow cube moves with it. However, if I rotate the red cone, the yellow cube does not rotate with it. This is the default behavior of the point constraint. Now I'm going to delete this point constraint and move the cube back up to its original position, and I'm going to apply it again, but this time with one slight change. I'll select the object that influences, then select the object that's going to be influenced, or the object that's going to be constrained, and I'll go to Constrain, Point, open up the options, but this time I'm going to enable Maintain Offset so that you can really see the difference between the point constraint and parenting. I'll apply. It appears that nothing has happened. However, if we look here in our outliner, you'll notice that the cube does have a point constraint to it. And let's compare how these two examples work differently, the parenting and the constraint example. So if I move the red cone, the yellow cubes move with it, and it appears that they behave identically. But if I rotate that red cone, you'll notice that in the point constraint example, that the yellow cube does not move with it. That is because it is only point constrained to it, it doesn't get its rotation in any way from this object here. This is how the point constraint works. In addition, the point constraint scale will have no effect on it. We'll now take a look at a third type of constraint. So to demonstrate this one, I'm going to once again delete the constraint that is currently applied to this yellow cube. So now you can see that once again the yellow cube is not being influenced by the red cone any longer. And this time we're going to try what is called an Orient constraint. So I'll select the object first that the yellow cube will be constrained to, and then I'll select the object that's going to be constrained, in this case the yellow cube, and we'll go to Constrain, Orient. Once again, I'm going to open up its settings and go to Edit Reset Settings just to make sure that it's set to its default, and we'll apply. One thing you may have noticed with the other constraints that we've applied, but I haven't pointed it out to you yet, is that if you select the object that is constrained and then you look at it in your channel box over here, you'll notice that some of the channels will end up having this little blue tick mark on it. This indicates that these channels on the object are being influenced by something else. So the Orient constraint, it affects the rotate X, Y, and Z on the object that has been constrained. So let's see what this Orient constraint does. If I grab the red cone and I move it around, you can see that it has absolutely no effect on this yellow cube. However, if I rotate, it will change the orientation of the cube. Again, we'll compare it to the parenting example. I'll move both of the cones. And I'll rotate both of the cones. And while I'm at it, I might as well scale as well. So the primary thing to understand about the Orient constraint is that the cube is Orient constrained to this red cone here, and it's simply taking its rotation or its orientation from the red cone, but not its placement in three-dimensional space. Again, we can move this cone anywhere we want, and it's not going to affect the position of this yellow cube here. It simply gets its rotation. If we were to select both the red cone here with the parenting relationship and the red cone here with the constraint, and we rotate it, we rotate them both, you get a very good sense of the difference between the parenting and the Orient constraint. Once again, I'm going to get rid of the constraint that's been applied, and we'll take a look at another example. So we'll select the object that the cube is going to be constrained to. We'll select the cube, which is going to be constrained, and we'll go to Constrain, Scale. Once again, I'm going to make sure that I've reset it so that we're looking at the default options here, and we'll apply. And this is a scale constraint, so obviously translating and rotating should have absolutely no effect. However, if I scale the cone both uniformly or non-uniformly, the same scale information will be applied to the cone as well. Now, if we want to compare these two examples, the parenting and the constraint, again, I'll move, or translate, rotate, scale. Before concluding this video, we'll look at one more type of constraint. So I'm going to get rid of my scale constraint right here. And we're going to take a look at the aim constraint. So once again, I'll select the object that the cube is going to be constrained to. I'll select it first, and then I'll select the cube. I will go to Constrain and Aim. We'll open up its options, make sure that we set it back to its default, and we'll apply. So now, if I rotate this, nothing happens. If I scale it, nothing happens. But if I move it, the cube will always look at the cone. Let's try constraining the cone as well to the cube. So in this case, the cube is going to be aim constrained to the cone, but I'm also going to constrain the cone to the cube as well. So we'll select the cube first this time, select the cone, go to constrain, and we'll do an aim constraint on that as well. Now, this illustrates that it actually is important, the direction of the constraint. So you can see that actually the cone is pointing away. However, if we want to test this, we'll just see what happens here. You'll see that both are in fact being influenced. Both are trying to look at one another. Let's see if we can get a little bit better of a result with this. So I'm going to select my cone here. We'll find the constraint that's affecting its orientation, which is here. And what I'm going to do is change its aim vector. Currently it's set to X, and that's why it is pointing in the direction that it's pointing in right now. We want the direction to be set to its Y instead. So under aim vector, I'm going to type 1 in its Y axis, and we'll set its X axis to 0. And now it's pointing at the cone. And if I move the cone, sorry, if I move the cube, it points at it. And if I select the cone, the cube points at it as well. Actually, they're always pointing at one another. So that is a quick run-through of constraints. In future videos, we'll try to take a look at some practical uses of these techniques of using constraints, as well as look at some more advanced techniques when using Maya's constraints. Hope that this video has been interesting for you, and thank you for watching.